Hi everyone, welcome to Masonry Design Requirements Part 2. We're going to go over the design properties of material and we're going to go over the performance requirements for design. So to start off, we're going to talk about the masonry unit. The masonry unit can be either solid clay bricks, cord bricks, or hollow masonry concrete units, concrete block. For our course and for design purposes, we are going to concentrate on hollow masonry units. But if you see here, you can find clay bricks and cord bricks, which are very common in construction. So the cores are these holes that are in the brick, right? And this is the face shell. We can we'll see there's going to be more detailed structures that's coming up. So next here is your, so this is a concrete masonry brick or concrete block. In this section here, we call it the head. This is called the face shell, and this inside here is called the web. The hole in the middle is called a core. Again, this is the face shell. This side is called the iris, and this side is called the head. Again, where you have cores in the middle, bricks with holes, they're called cores. And this is the face of the brick, and anything with the indents in it called the frog. These are the typical masonry units that we find or we're going to deal with. Next up are the common sizes of a solid clay brick and a hollow concrete brick. So a solid brick, it's usually 230 millimeters, whereas by 76 by 110 millimeters, and has a strength of 10 MPa. Hollow concrete bricks come in different sizes, but the one that we are going to use usually is a 390. The most common one is a 390 by 190 by 190, and the strength is 15 MPa, and its thickness is anywhere from 90 millimeters to 140 millimeters. So let's keep that in mind, that the most common one that we use is going to be a 390 by 190 by 190. Again, when we go, and we can find catalogs out there for different types of bricks, but this is the most common one that we use. Then you have the mortar. Mortar is the binding. It binds the masonry units together. It provides protection against penetration from air, water, through the joints in the masonry assembly. So it combines everything together and it makes it weatherproof. It bonds the non-masonry elements of the assembly, in example, joint reinforcement and ties. So if they're putting any ties in there, it joins the brick to that. It joints contribute to the architectural quality of the masonry, so it also has to match the color of the brick. So you can find mortar, you can add different pigments to the mortar so that it matches the color of the brick. The mortar basically functions as a glue, and it has a plastic mixture of cement, lime, sand, and water, and is usually specified as cement lime sand ratio is called CLS, and it consists of cement, which is the binder, the sand, which is the filler, the water, which is the mixer, and the lime is put for workability. And then we add other admixtures based on the requirements, but this is the most the CLS are the most common ones, and you will find that when you look at different ratios, there's different ratios used in different parts of the world. Also, another interesting thing is mortar takes up about 20% of the wall area. So if you have a walled area, you can almost say that mortar takes up about 20% of that wall area. Now, there's in Canada, or according to CSA standards, there's 5 different types of mortar, and they are given by the code for MSNOK, and they're usually used by mason work. So we say mason work, and all the second letter in that is the code for the types of mortar. So there's type M, there's type S, type N, type O, type K. Type M is the most strong and it's the least workable. Type K being very weak and very workable, but the one that we use the most is SNN. So we have to we have to stay somewhere in the middle, and we can't have something too strong or too weak, so we usually use S and N, which is typical for our construction. All of these have different uses and workability. So we can see type M, S, N, OK. These have composition parts, and they have different compressive strength. So let's say, for example, type M has four parts cement, 1 part lime, and then 12 to 15 parts of sand. So this is how we say the CLS combination. You can see here for the different types of mortar is what we use to get us the different strengths. Now we use there's a guide for selecting the right type of mortar that we use. You can see here for type N, it's used for above grade, exterior work, interior work, load bearing work, and soft stone masonry. That's where we use type N. Type O is usually used for above ground, interior, non-load bearing work. Type S is used for below grade masonry foundations, manholes, retaining walls, sewer, brick patios, and pavement, which is type S is a very common one that we use. Then you have type M, which is used for heavy loads, masonry below grade, foundations, retaining walls, and driveways. So this is an important guide for selecting the right type of mortar and for which application we use, right? Next is how the mortar sits on the actual brick. So if it's a full brick, it's called a full bedding for solid and cord units. So for solid or cord units, you put a full bedding. If it's a hollow unit, we call face shell bedding for hollow units. So you can see only the two ends here. You have bedding, right, on the sides, and here you can see the length and the width of the area covered by mortar. It's important because when we go into design, sometimes we have to figure out how much mortar we're using and your effective area, your AE, how to calculate your effective area to see the adhesion between the bricks. The mortar joints are also common types of mortar joints. So you also have, depending on the type, it can give you different looks. You can have a concave joint, you can have a V joint, you can have a rake joint, or a flush. So depending on the look that you're looking for, you can use different tools and different techniques to get the concave. You can have a concave tool to give you that concave look. You can have an edge or reed tool to give you that V look, and vice versa. So there's different types. These are the common ones, but there's many different types that you can use to give the different structure. It also comes in various different colors. You can either have a color that blends with the brick color, or you can have a contrasting brick color, so it will be in contrast with the brick color. So this way it gives you a lot of different options of selecting the different types of mortar and brick together to give you a better look. So that's why it's also very important, or it's a very this is one of the advantages of using brick and mortar. Grout. It's similar to mortar, but it has a higher water content. It's used to fill cores or cavities in reinforced masonry. It should be matched to the masonry unit strength, but not less than 12 MPa. Its slump is typically 230 millimeters. So it's usually used to be poured in between where you have reinforcements. So wherever we have reinforcements, we usually use the grout. It's essentially to ensure that there's composite action between the grout, between the rebar and the grout and the concrete block itself, especially designed to avoid segregation. Because it has such a high slump, there will be minor segregation. Minimum cement content is around 300 kilograms per cubic meter, and you have to care is needed during construction to avoid blowouts because it is heavy. So you can see you have to make sure the blocks are supported properly, otherwise you'll have a blowout at the bottom and all the grout will come out, so because of the hydrostatic pressure. So we have to be very careful when using grout. that the concrete blocks are supported properly at the bottom. Next is the wall ties. These are ties that are joined to leaves of cavity walls, or let's say if you are you have a wood structure and you have a brick veneer, you use wall ties to connect the brick veneer to the structure. It could be either wood structure, steel structure, another block structure, but we use the brick connecting to the block, or that or vice versa, using either typical metal wall ties, or there's also polymer wall ties, but they're not too common. We use typical metal wire ties in walls. Next is reinforcement. Reinforcement is the same that we use in concrete construction. It's placed in grouted cores and cavities, and you need to care regarding spacers, bracing to ensure there's correct placement. So when you place these, you have to make sure that the placement is correct, and you have some spacers used to hold that rebar in the middle to give the right compressive or tensile strength that's required. It has two purposes. The primary reinforcement is to resist compression, bending, shear, tension, and any combination above that. And the second reinforcement is to resist the shrinkage effect and temperature effect. So it will help in those two are the primary things that it helps in reinforcing. So you can see here this reinforcement, and then it is used as tire wire is used here to combine different rebars, and then it's grouted in, right? A typical reinforced masonry hollow unit. So we put this is called a single leaf, where you put rebar in one of the blocks, every second block, and then the cavity reinforced backing, and you have the clay brick veneer. So you have the brick veneer on the outside. Other is reinforced cavity. So if you have a cavity wall, you can put rebar in the middle of the cavity wall. Or when you have a pilaster, you can see here a pilaster or a column. In the middle, if it's a hollow column or pilaster, you have reinforced pockets in there. That's another typical masonry wall reinforcement that we use. Another thing that's used for design is expansion and contraction joints. A joint or gap constructed in masonry to control the absorbed movements of the masonry. So let's say if we have a long wall, due to heat and cold, these walls tend to move. So we have to keep expansion joints when we have a long wall, and these are we use them with sealants. So we put in the wall in the middle, we put sealants, and when it expands, the sealant compresses and it makes the joint in the middle. So separate masonry into segments to prevent cracking caused by the changes in temperature, moisture, expansion, deformation, settlement, and creep. So it helps with all those things when you have a very long wall construction. You can see here you can use different types. You can use a foam strip or a neoprene pad, and you can move. You can even see in the corner there's movement at the corners without expansion joints. So you have to be very careful. And corners we put expansion joints. We even put expansion joints when we're doing long concrete structures, such as when we're doing curbs or sidewalks. You'll notice while you're walking, every few or every 4 bays, you'll find that there's a black pad that's there. That's an expansion strip that we use in concrete. So it's not just masonry, it's also used in concrete. That's typically used for expansion and contraction of the concrete or brick. So you can see here are more examples of the expansion joint, right? So because it's expanded, it's coming out or bulging out, and it helps to. And here you can see, because there's no we did not put an expansion joint, the edges are moving out. That's why usually you'll see if it's a long wall and close to the edges, you'll find expansion joints in buildings to avoid this situation happening. Masonry wall construction terminology. So it's important to know these. A course is a horizontal layer of units. So if you have a horizontal layer of units, those are called course. You can see here the perpendicular joints. These are the perpendicular joints, and the horizontal joints are called bed joints. The horizontal brick laid along the wall is called a stretcher. So you can see here one piece of brick is called a stretcher, and a half piece or a portion of a piece that's used at the end is called a closer. So it's a brick which is less than full size, but it could be half or 3/4 depending on what's required. It's used to bring the end of the wall to a vertical face. So this is very important and common terminology that you will see being used in masonry wall construction. A bond is a pattern in which the bricks are laid. So you can have a stretcher bond, which is very important to know. You can have a header bond, which is going parallel to the wall. If it's put on its side, that header bond is called a roll lock. If the brick is put like this, it's called a soldier. Again, if it's put on its side, it's called a sailor. And if it's put like this, it's called a shiner. So these are terminologies, common terminologies, and different unit orientations. You can see here the way they are installed. So these are soldiers, and these are the stretchers, right? Now the different combinations there's different types that we call, and very common ones. The common ones that we use are a stretcher bond, an English bond, and a Flemish bond. In a stretcher bond, every course is offset half a brick from the course below. So you can see here, this is a typical wall section, which is called the stretcher bond. Every course here is on top. You can see that it's offset half. In an English bond, which is down here, you can see one course in the stretcher and one course is a header. So one course is straight line stretcher, and the one on top is a header. So they're all laid on the side or perpendicular. So we going like this. In the Flemish bond, you have a stretcher next to a header in one course. So in the same course, you have a header, a stretcher, then you have a header, then you have a stretcher. So you can see this line going. You have a header, stretcher, and then you keep on going. So these are the three main types of bonds that we use in wall construction. English and the Flemish bond are very typical for load-bearing walls on the outside, and a stretcher is a common one non-load-bearing wall, right? Now we go into the performance requirements for design and the aim of design. So the aim of design is to provide a structure that is adequate for the strength, stability, serviceability, fire resistance, and durability. Additionally, it's particularly for masonry structure. Other relevant requirements for water penetration, you have robustness, ease of construction, and economy. According to limit states design format, what we want to see is that demand is less than the capacity. So that's what we designed for. And meeting the performance requirements leads to longer service requirements. So there's the performance requirements that we need to look for, and the better we can do those, we can get a longer life out of it. According to limit state design, there's two major categories. You have strength and serviceability. For strength, we check the design load is greater than the design capacity, the design load is less than the design capacity. We design for that. And then we check for its actual deflection, which should be less than the allowable deflection. So those are the two checks we do, not just in masonry, but also similar as concrete. We're doing the same things. We're checking for design load, and we're checking for deflection to see if the beam it matches the design capacity or allowable deflection. So the performance requirements that we discussed, you have to have serviceability. You should have low probability of failure and remain serviceable and fit for purpose throughout the intended life. Then you need the strength, have a low probability of structural failure, under loads that are reasonably expected throughout its indented life. Stability, have a low probability of instability under loads that are reasonably expected throughout its life. Then you have durability, withstand the expected wear and degradation, accounting for exposure to environment and importance of the structure throughout its life. And then fire resistance, perform its structural function, and if necessary, prevent the spread of fire. So wherever it's required to prevent the spread of fire, we can use this. Other requirements based on the appropriate design requirements, water resistance to water and whatnot, right? So those are the performance requirements that we use to design masonry walls. Similar to concrete, you have the compressive strength of a concrete unit block, and that's given by F prime M. For concrete, we had F prime C. All the calculations are to design are the same. We just use different compressive strength. So the compressive strength for masonry unit block is F prime M, and it is affected by three major things. It has the tensile strength of the masonry unit, the mortar joint thickness, and the mortar strength. So the tensile strength of the brick masonry unit is a function of the material expansion of the mortar and the degree of firing and the coring pattern. The mortar joint thickness is highly stressed load-bearing walls. Thicker mortar joints increase the splitting force. Therefore, these structures, the joint thickness is best limited to 10 millimeters. So the joint thickness should be limited to no more than 10 millimeters, right? And the mortar strength is the mortar with the low strength generally has lower elastic modulus, resulting in greater lateral expansion under the load. So F prime M is a function of tensile strength of the masonry unit, mortar joint thickness, and the mortar strength. So all of these three combined together is F prime M. So here's a table that shows the F prime M that are from CSA standards. F prime M is a masonry compressive design strength. It is less than the masonry unit strength due to the effects of mortar bedding and the interaction of mortar in the masonry unit. So as we can see, the tensile strength of the masonry unit, the compressive strength of that unit block itself is different from F prime M. So you can see here, which is a typical 15 MPa block, its actual F prime M, compressive F prime M, is 9.8 for a hollow block, and for solid or grouted, it's 7.5 MPa. So that's a very important thing, that the compressive design of a block itself is actually different from the compressive strength of a masonry compressive strength. So F prime M is a combination of those three: your tensile strength of the block itself, your mortar, and the thickness of the mortar. So those are very important to know, and going forward, we use the same design criteria and the same design steps that we use for concrete to design for masonry walls. Another important thing that we use is different from concrete is the elastic modulus for masonry. This is calculated using E is equals to 850 F prime M. So once you know your F prime M, you can multiply that by 850. That will give you your elastic modulus. But it cannot be greater than 200,000 MPa. There's a typo, should be 200,000 MPa, or maybe determined by testing. So according to CSA, also provides method for determining effective moments of inertia for deflection calculation. So we have they have tables for deflection and inertia. And that's it. Thank you guys, and we'll go forward after this. Thank you.